Hello everyone, it's February 20th again. We're going back to the old schedule of doing a night. Alright, so it should be fine today because it's an easy one. Just get this done and I opened another intermediate, another medium one. Yeah, so let's take a look. Majority element. Oh, let's pretend we haven't seen that. Wait, how do I reset the default? Alright, so we've done this one. Oh, that was uh that was just a little bit over a month ago. Okay. Given array nums and size and turn, the majority item is the element that appears more than. Okay, you can assume that the majority will always exist. I believe this is. I'm not gonna do two different solutions because I've done this before. So counter it is. Yeah, just gonna do a counter. So collections port counter, and then we're gonna do counter nums dot most common 1 0. Yeah, I'm pretty sure that's the solution, but to check. Oopsie daisy. Shall be 0 0. It says the majority will definitely exist, so that should be the case. I'm pretty sure that was this solution. Could be this one. I'm not 100% sure. I think it's this one. I use counter. Yeah. Alright, so that's that. You still need to record this. This is what? 169. A very simple problem. Also solved in okay. Alright, let's do this one. Continuous subarray sum. Given an integer array and an integer k, return true if nums has a continuous subarray of size at least 2 whose elements sum up to a multiple of k, or false otherwise. Integer x is a multiple of k if there exists an integer n such that x equals n times k. 0 is always a multiple of k. And then I'm pretty sure n has to be oh, no, all positive because all the values are positive. Okay, that makes things a little bit easier. So I just need to return true or false, right? Just true or false. If there exists at least one continuous subarray that sum up continuous subarray, the first thing in my mind is cumulative sum, right? Cumulative sum. Has to be multiple of the k. if I have a cumulative sum, right? I have cumulative sum, and I will put all of these into, let's say, a dictionary. And I would not dictionary. We can put them into a set. That's fine. And then for each one, right? For each one, we try to see if, because it has to be sum equals the multiple of this, right? So we're going to be multiple of this minus the current one, and see if we have something inside on the left side, right? If we have, means this minus this value minus this value equals a multiple of this, right? Okay, hold on. This minus this, so this minus this equals multiple of this, which means this will equal to this plus multiple of this. So we can go front one by one to plus multiple of k, and to see if there exists a value in this that. So what we can do is, we know the maximum value, right? So this plus multiple of this can not larger than this. So we just iterate through for everyone, iterate through, and just see if we have. Or, and there's no or, because the number line is 10 to the 5th. If we go through every single one, that's going to be O(n) squared. That would be too slow. We don't want to go O(n) squared, and that's too slow. So we want to work directly with k. So at least we can have a total sum divided by k. Have to go through that many times. I'm thinking, can we do better? Can we do better? Plus 6. Next one is plus 12, right? Well, honestly, because we start at a certain value, so the total number of k's we can add is actually gets smaller and smaller as we get closer to the end. Actually, no. Okay, the value is 10 to the 9th. It could be gigantic. Well. It might not be, because some of them is smaller 2 to the 31st minus 1. I'm just afraid of my timeout. That's the only thing I'm afraid of. I think in my timeout, if I go K, 2K, 3K, 4K. So I'm trying to think if there is a better way. Binary search. How about binary search? Because the prefix sum are sorted, right? And how can we use binary search for this? It's sorted. We're going to find one of them such that this one minus the one we have is equal to multiple of k. I'm not sure, man. I am not sure. I could go through the entire thing. That's the thing. I can go through the entire thing and then not finding any. Like for this one, right? iPhone 23. Wait, I can't. Oh, it's 2, 6. My bad. I didn't see that. So 26, 23 didn't work because plus 6 is not in there. Plus 12 might be already explode. So we do this is no good. This is no good. Well, times 0. 0 times 6. Right? So plus, wait, hold on. So we plus 6. So we need to find if something is in plus 6. So, okay. So every single one we have to check itself. Right? Basic just means we have a 0 at the front. And then we have all this and then try to see. Imagine k is 1. What if k is small? Alright, if k is 1, that's fine. The first one will be found fairly fast. I'm not sure about this 1 by 1 thing. But the other one is O(n) squared. I'm not sure about that either. I don't know, man. What would be the best strategy? It depends, right? If k is big, then we do k. If k is small, probably should go through 1 by 1. Again, a cumulative sum is an increasing array, right? And what we want to find is any pair whose difference, right? This minus this, any pair is a multiple of 6. Any pair as difference is multiple of 6. Okay, can we use like the information that's already gathered previously? Let's say I already find out that we go from high to low, right? So the largest one is not. Yeah, so every one needs to, so I want to add something, right? Add something. Add 6. Well, everybody needs to first check itself if it's divided by 6. And then if not, we're going to add 6. And the biggest one, I can add 6 and it explodes, so we don't do it. So the second biggest one, right, I can check and then I add 6, add 2, 6. So as I go, what I know is, right, what I know is the larger one cannot find anything. So this one, the larger one, plus 6, like plus everything, did not work, right? So none of those. But how does that help me? Right, how does that help me? All I know is those guys, plus 6, plus k times whatever multiple, cannot find a thing. How does that help me? Gotta be I don't know. I honestly don't know. I'm just gonna try this and see if time times out. If it does time out, we come back to think again. But right now, I really have no other clue that I can put into use. Right now, all I think about is just the solution, which honestly, I feel like it's gonna time out. Let's try. But never know. So accumulate. So we'll have a pre-sum equals a list of accumulate nums, right? So we can go from back to front. Okay. Yeah, let's go from back to front. We say for I range and pre-sum -1, -1, -1, right? Everyone, we are going to check if pre-sum I is k equal to 0, return true. If not, while, oh, I just realized something. I need a pre-sum set, right? While pre-sum I k, right? So k prime equals k. So while this plus k, while this plus k is smaller or equal to pre-sum the largest, if pre-sum plus kp actually, kp plus kp is in pre-sum set, return true. Otherwise, kp plus equal to k. And now we try it again, right? Until we exhaust. Once we exhaust, we just go. If nothing, we're return false. I think this is right, but again, this is yeah, I fear it is going to time out. Like seriously, I fear it is going to time out. This one is true. Second one is very similar, but I think they changed this from 6 to 4. The last one is 13, which is false. What is that? Can only concatenate list to, huh? What the? What is this? I don't know what happened. I honestly I have no idea. I don't know. Pre-sum, KP. Pre-sum. Pre-sum. Oh, I'll pre-sum I don't know what happened. All right. Plus KP, smaller equal to if this is in, then return true, otherwise KP. Okay, why? What happened? What actually happened? Pre-sum I, that's just pre-sum I, what's KP? Pre-sum is this, pre-sum is 29, 29 plus 13, it is 42, it is here, 25, 25, 29, so 42 minus 29 is 13. 2, 6. 23, 2, 6, 4. Ah, my bad. That's 6 and 4. Alright, I seriously hope it's not going to timeout, but I have no clue in my timeout. We see. Oh, we got a wrong answer. That's even worse than timeout. Wow, I have hit a lot of wrong answers today. That was bad. Which is false. Don't tell me I give it a true. Oh, 0. Oh, shoot. Shoot, and shoot. So KP is 0. Darn. What do we do? Then we have to use counter, right? We have to use counter for this. And then when I consider myself, I minus myself, right? Yeah, minus myself, and I start with 0. And if this is equal to larger than 0, right? And once I'm done, I give it back. Okay, so that's actually a good. This is called counter equals counter pre-sum, and then blah blah blah. That shall start with 0, and then counter pre-sum I minus equal 1. And if this smaller than this, if counter pre-sum I plus KP is not equal to 0, right? Larger than 0, that turn true, and otherwise we keep trying. Once we're done, this one plus equal 1, so I have a reverse. Yeah, now we're right. Again, hope is do not time out. Oh my god. You gotta be kidding me. This is terrible. That's true, right? No. No, this is false. What? Oh, what in the world? How? And minus 0 to 1, the first one is 0, right? And 0 mod k. I think it's because 0 mod k. Wait, the value can be 0. Value can be 0. 0 mod k. Can we just remove all the zeros? What does a 0 do? It doesn't do anything. Consecutive. Yeah, if you think about consecutive, 0 doesn't mean anything. Well, it does, right? Because in here it makes sense. This is true because hold on. Consecutive. Oh, pair. Damn. It has to be pair. And I just realized something. It has to be pair, which means if the prefix sum is a single value, no, not a prefix sum, a single value, we have to consider the first one separately because the first one is by itself, right? So what we need to do is, instead of going to -1, we shall go to 0. We shall not consider the first one by itself, right? The first one by itself is not correct. But if we don't go, now we have to add, no. It is if it's the first one, right? We're going to say here, if I is larger than 0, and so when we consider it by itself, I cannot include the first one. So yeah, my god, anything else you're gonna throw at me? Here it is. It's throwing me a new thing. What the heck? What the heck? What's this? 1, 0, and 2. Output true, expected false. What? Why would I say true? We got 0. 0 by itself. I was thinking that the front. It actually can be front. Oh wait, hold on. No, there's no 0 by itself. What I have is a 1 and a 1. Right? I have a 1 and a 1. Darn. It could be the same. Oh my god. Oh my god, all the zeros. Yeah, because I got 1 and 1. And that last one cannot add the 1 in the front. Have to add the 1. Oh my god. Then what? Now what? Zero is all sorts of trouble. Alright. How about this? We hate zeros, right? 0 is just absolutely the worst. can we remove 0? Like, I don't want to consider all these just ridiculous cases. Well, if you want to remove 0, we can say, like, if there are consecutive zeros, like a 2, 0, right, consecutive, then it's a true no matter what. But if there's no consecutive zeros, then those zeros are useless, because I don't include it, I include it, it doesn't really matter, right? It doesn't really matter. So I shall just remove it, which means I shall create a new one by handling the zeros first. Otherwise, how can I just, like, I'd expect everything to be increasing. Now you're telling me that we can have repeats. If I have repeats, it doesn't work. Screw this. I'm gonna do it. So what are you going to do? Well, what I'm going to do is what are you going to do? Remove all the zeros. I have to go to one by one. Right? I have to go to one by one. If I go one by one, why don't I just do the prefix sum at the same time? Right? Okay. Yeah. So pre-sum equals this. Pre-0. Let's call it false. For n in nums. Okay. If n is equal to 0 and pre-0 is true and pre-0, then we have two consecutive and immediately return true. Otherwise, if actually we should do this. If it's 0, right? If this is true, return. Else, then we say pre-0 equals true. And then we don't do anything, right? So in else, if it's 0, I don't include anything. Else, if it's not 0, then pre-sum. Actually, I can put a 0 here, right? And pre-sum. Should we put a 0? If we put a 0, I don't want to put a 0. So we just say else. Now we can put a 0, but we don't, when we do the counter and stuff, we don't, I don't like it. So if it's 0, else, if this pre-sum dot append, probably can do in one line. Alright, pre-sum dot append n if n plus pre-sum minus 1, if pre-sum, else n. Alright, and then blah blah blah. Once we're done, we don't need this, so we do the counter. Now we're gonna go this, it's the same. and we'll go this, we minus equal to 1, right? And then we handle this one, yes. I'll just see the solution gets more and more complicated. Let me see how many errors can we accumulate? Oh, we have more. What the heck? That's false, right? How did I not detect this one? This is a 1, 3, and 15, right? 1, 3, 15. 3, 1 plus 2 is 3, and 3 plus 6, and 3 plus 12 is 15. So that's, oh, I see. I did not consider that part. It cannot be the 1. It cannot be a single value, which means if this, makes you wonder, right? It makes you wonder. So counter, it has to exist, and this one cannot be the next one. Okay. Hold on, let me think again. Now we guarantee everybody is unique, right? If everybody is unique, then for every one, I need to check myself, except when I am at the beginning, right? But that can be avoided if I add a 0, right? If I add a 0 and I go from 1, then it'll be this plus something. Yeah, I don't check myself. Wait, do I check myself? I have this, right? And then we add. And this we add. And this, everything we add. And this one is the start. Then we add. And this one, then we add. Okay. Then we do this. And then we do this. And we do this. And we don't have to check this. Right? And we can set it to K. It's fine. We don't have to do this. We just say if it's smaller than the last one, if this and pre-sum I plus kp is not equal to pre-sum I plus 1. And I don't worry because of short circuit. I is the start. I plus kp definitely will be larger than, so I don't worry. Right? I don't worry. And because I have a 0 at the start, so at the end I have all this, and I don't have to worry about this either. And in this case, I don't have to worry about this. It's not gonna be it's just gonna be a set, right? So it's just gonna be a pre-sum set, and call a set on this, and this is just this in pre-sum set. In the set, and this is not equal to. Alright? Oh, Lord. Lordy. Come on. Now TLE. Wow. No, it's not TLE. Output true. Jesus. How many times can you be wrong? And this one it should be false, right? And I got true. Okay, what I guess should be 1, 2, 3. How is it possible? If you print pre-sum, actually I'm gonna just comment out this so we focus on the last one. Huh? Ah, pre-0 equals false. My God. Ah, that was okay. That was a small mistake. That was a small mistake. Mistake nonetheless. Mistake nonetheless. I forgot to do this. Yeah, because I really do not like consecutive zeros. That was a mistake. That was a mistake. Not algorithm wise. What is it now? What? How? How? You gotta be kidding me. Oh my God. I just keep failing. What the heck? Oh man. I see. I see. I see. What the actual F? Hmm. We do not remove zeros. We do not remove zeros. Then the prefix sum. No, we still remove. But, gosh. But, hold on. Let me think. we'll have repeats, okay? Which is fine, right? Repeat is fine. And for each value, we need to add, we can add 0, right? If we add 0, we need to go certain number down and try to see from this to the end, do we have a value, right? Right? Which means if we use a counter, if it is a non-existing counter, then it's a no-go. If it does exist in counter, then what we need to know is if it does exist in the counter. It'll be like this. We find a value, right? A current value. We add k. We add 0k, 1k, 2k, whatnot. And for each one, we check to see if it is in the set, right? If it's in the set. And if it's in the set, now there are two situations. If it's the same as myself, right? Which is the case at the beginning, because we say just plus 0 is itself, right? If it is itself, that means we have to check current index plus 2, right? If current index plus 2 is the same, that means we have a 0, 0 situation. And a 0, 0 situation is good no matter what. But if it's not, then it's a no-go, right? Then it's a no-go. Well, yeah, then it's a no-go. Else, if it's not equal to itself and it exists, then I just check the next one, right? If it's the same, not really, because it could be this and then 0, right? So we still need to check two up. So we get a value, we check 2 up, and if that value is smaller or equal to the target, then it's a good, and then it's a go, right? That means it should be somewhere down there. But if it's larger, then that's a no-go. Okay. So we handle everything plus, everything plus, and we also need to handle themselves. And I have 2, so the first one cannot do. The second one we can do, right? The second one we can do. Stupid, stupid, stupid. I don't like any of this. I am actually annoyed. This is ridiculous performance. So bad. So many edge cases. I've never seen edge cases that many throughout all of this. Okay, so we're gonna start with 0, right? Well, actually, before we start with 0, we should also say if I is larger than 0 and pre-sum I mod k is equal to 0. In this case, we return true. Okay. Otherwise, we do k is this, and then while this plus this is smaller or equal to this, right? And then we say if this plus this is in pre-sum set and this value and it's init, and the question is, why do you do on the last one? The last one I cannot add anything, right? And we don't even do, so the last one and the one before the last one, neither these two can work, because if we want to go this to the end, we don't have one value. So those two are not going to work. So might as well just, we don't do -1, I cannot do. -2, I cannot do. So those two need to be considered by themselves. It's impossible from this one. What if this one and this one? That's this, right? This minus this. So -1 is no go. -2 is no go. So it should be from -3, right? Start from -3. I is -3. And then we say, well, this is smaller or equal to this. That makes sense. This plus this is increase, and this, and now I can say, right? Now I can say, what I say is, and this plus 2, because it has to be plus 2, is smaller or equal to, right? If it plus 2, this is smaller or equal to this, and we know this is inside the preset sum, and this is smaller or equal to, that means either pre-sum I plus 2 is equal to this, which is good, or if it's smaller, that means something even bigger is in it, right? Something is even bigger is in it. But we'll also set this, so okay, so this looks promising, but eventually, actually not eventually, we should do it beforehand. So blah blah blah. Okay, this is good. And then we're gonna say if pre-sum -1 mod k equal to times pre-sum -2 mod k. Well, how do we have a -2? How long is it? Could be 1. So we don't have a -2. Screw you. Okay, so goes 0, turn true. Right. If len pre-sum is larger or larger than 1, and this is equal to 0, right? Turn true. These are the two edge cases. Is 1, the last one, and on the check 2, then the length has to be larger than 1. And we can check 2. Okie dokie. 4, 0, 1, 2, 3, 4. The heck? Ooh, okay, how about this? If randoms is equal to 1, return false, because it's not going to be possible. And then we don't have to do this. And we can say this, right, multiplied by this equal to 0. So one of them, right? Then we'll return true. And then the rest. How about this? Mind ya, we still haven't resolved the problem of possible timeout. We're just handling all this stupid. We did pass, but oh my god. My God, I have to avoid this problem. This is a nightmare. This is a nightmare. Jeez. How many times it can be wrong? Screw me. One of the worst case of trial and error in all of my journey with LeetCode. A number of edge cases is through the roof, and it really frustrated me. Yeah, the problem is with two things. One is the existence of zero, all right, and the other is the case where a single number can be divided by k. Eventually, I settled for the prefix sum solution. I check from back to front, right? From back to front for each prefix sum, whether it plus a multiple of k exists in the set of prefix sum, and to assure that if such a value exists, it does not occupy the position right after the current prefix sum. Also, the last two prefix sums, if exist, must be evaluated on their own. Well, I don't know what's the runtime. I think the runtime is pretty bad. The O, N, because that's prefix sum, right? And then everyone is going to be times max nums, right? Basically, it's max num divided by k. Yeah, it's not a good runtime. We have to check the solution to see what is a good solution. This one just feels so bad. God, so many errors. There's a math. Wait. That's the same idea, a running sum. That's the same idea. Running sum, and we push into the map, that's fine. And a mod k. Look at this one. Look at this one. Mod k. to avoid doing this. So every time I will mod k. So the math behind this is what we find is this value, the current value, minus the previous value must mod k. Well, yeah, mod k must be equal to 0, which means current value mod k minus the previous value mod k must equal to 0. So, freaking awesome. Yeah, the remainder. Wow. And I can avoid a lot of the issues. It was very generous of the online judge that allowed my solution to pass. I do not have any complaint if they do not pass my solution. There's no complaint because it's not ON. Right? It's worse than ON. That's the trick. That's the trick. Now I see the trick. So the trick is mod. Ah, come on, man. It is the mod. The trick is with the mod. So for the reference, and let's try to write it ourselves. Okay, so the reference solution has the same idea, right? The same idea, but it solves the problem of how many Ks to check in O1 time. We simply mod each prefix sum. I note that what we want, right? What we want, if we want is to is that given the current prefix sum, what we want to find, what we want is that given the current prefix sum, we want to know whether there exists a previous prefix sum such that the sum current minus sum previous, right, is a multiple of k, which is equivalent. Let's call it this is equivalent. This is equivalent to, say, sum current minus sum pre, right, mod k is equal to 0, which is equivalent to sum this current mod k minus sum pre mod k equals 0. Thus, if we keep track of the remainder of each prefix sum divided by k, we can avoid the problem of having to find how many k's to deduct or add. And then the other thing to keep in mind is to avoid a match that is right behind or in front of the current value. So that is the trick. So multiple of k we can mod, right? And what I know is if you add something, right? You add something, you do the mod, is the same as you mod and the add. How did I not click? How did I not click? I shall be able to click here, right? I shall be able to click here. I don't have to keep the k plus k. I just know if everyone is mod, then it just should be the same. Alright, so pre-sum 0, right? And we need is its prefix sum, and I want its index, right? So let's just call it hash map. Hash map is going to be this, right? So when they put 0 into it, I see that one has to be, because the current one minus, I need to say the current one minus this need to be larger or equal to 2, or larger than 1, right? Larger than 1. Okay, so what do we do? For n in nums, in enumerate nums, okay, pre-sum plus equal to, right? Plus equal to, actually, pre-sum equals to pre-sum plus n mod k, right? We mod every single time, and after that we say if pre-sum actually say, what do you say? If I, right, need to be larger than something plus 1. What's that something? That something is hash map dot get. Get what? Pre-sum, because they're the same. They're the same. The pre-sum occurs, which is just the mod k value. And what we're gonna do is, if I is larger than this plus 1, so what is the default value you want to put it? So always to make it false if pre-sum does not exist. Pre-sum does not exist, I can put in I, right? That doesn't matter. That doesn't matter what I put in. If I put in I, then this will always be false. So it's fine, right? It's fine. It doesn't matter. But it has to be larger than this, which means the ones I pick is at least 2 values in front of me. So if I is larger than the previous one, right? Yeah, if it's larger than the previous one, then I shall return true, right? Let's return true. It just means pre-sum exists at a value to make it. Now we need to update hash map. Right, so hash map pre-sum. What do we have? Multiple. We want to record the smallest because the smallest has a higher chance, right? So I want equal to minimum. Minimum of what? Minimum of, if it exists, right? If it exists, or I. And if this, then return false. Okay, I have tons of test cases. Very nice. This is a win. All right, let's see. $904. Yep, this is the right answer. Good problem. Very, very good problem. I think, how should I say it? If I were careful enough, this one will pass, like in 1 or 2 attempts. But I don't know. I just got a little bit disoriented. I think I got frustrated. Whenever I got frustrated, it's hard to take a step back and then calm down and 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 think it over. It's like, when you got to like maybe 3 or 4, you should just stop. Right? Stop. This is not working. Calm down. Think about it over. But I never realized the mod thing. Yeah. This is where the magic happens. Alright, it's a very good problem. Got humbled by the medium question again. Alright, that will be it for today. I'll see you guys tomorrow. Adios.